In this week's podcast, we're talking to a streaming data expert from ThoughtWorks. You might know him. It's Simon Aubrey. And he has recently won the Confluent Hackathon with a really great project. It's a fun use of machine learning and some field hardware and Apache Kafka. He has been using Google's TensorFlow to do some AI stuff to track the animals of the Australian outback. Well, technically the suburbs of Sydney, but it's outback enough for me. I thought we'd get him on because I was on the judging panel for the hackathon, and this project really hit that sweet spot between doing something fun and cool and playful, but then you step back for a second and you can easily see some real-world use cases that he's addressing with really just a few hundred lines of code. It's really great, and we're going to link to the project in the show notes. But before we get started, this podcast is brought to you by Confluent Developer, which is our education site for Kafka. You'll get more about that at the end, but for now, I'm your host, Chris Jenkins. This is Streaming Audio. Let's get into it. Joining me today is Simon Aubrey. Simon, welcome to the show.
Hi, Chris. It's an absolute pleasure to join you today. Thanks for having me on as a guest.
Oh, it's great to have you. Last time we met, we were in person. I was on the other side of the planet with you in Sydney. We'll have to make do with the wired link this time.
Yes. But I do appreciate that you made the long voyage out to Australia. It was so good to see you in person.
It's always great to meet people in person. I used to live in Sydney, so it was nice to be back, if only for a while.
I'm sure it's changed a bit. Anyway, it's great. Anyway, it's definitely great to be able to join you on streaming audio today.
Oh, it's a pleasure. So let's say in Sydney, you work for ThoughtWorks as a principal data engineer. What is a principal data engineer?
So I think I'd describe my job as doing cool things with data. If I was to...
Isn't that the whole of computer science?
Absolutely. But I think if I was to try and do this as an elevator pitch, I'd describe it as doing interesting things with highly available distributed data systems. And that typically gets me in the door with clients, and they might be in the worlds of finance or transport or healthcare or insurance. But it's definitely an interesting overlap with interesting business problems and the opportunity to play with really cool technology such as Apache Kafka. And I also love to mix it up and play with some sort of concepts that come out of data mesh, and the concepts of data mesh and data streaming platform seems to be a nice sort of overlap. So yeah, it's an interesting place to play.
It sounds like a sweet gig, to be honest.
Yeah. Oh, for sure.
But the idea of play is why you're joining us this week, right? Because we recently held a hackathon, and you were our glorious crowned winner.
It was a fabulous opportunity to essentially have some of the typical constraints of day-to-day project life removed and start thinking about, left unshackled, what cool things could you build? And I think the challenge out of the Confluent Hackathon could essentially be boiled down to do something cool and something that interests you with Apache Kafka. And it's great to have the opportunity to play with cool tech.
Always. So tell people what you built, and then we're going to go through how you built it.
Absolutely. So I think the short summary would be this is a wildlife monitoring system. And as any good hackathon would have you, would be mixing technology with a real world problem. And I essentially wanted to solve for how could you identify animals in the wild, count them, and essentially work out where they were and maybe draw some insights around population trends and animal movements. And it's particularly good to be able to use something like Apache Kafka, streaming technologies, and an excuse to use a Raspberry Pi.
That's all you need for a hackathon project, right?
Oh, absolutely.
And you live in the best place in the world for wildlife tracking, because doesn't Australia have more things that can kill you than any other continent?
That might be quite a stretch, but it was definitely a bit of an advantage of having an Australian back garden. So I literally put a Raspberry Pi in the back garden with a camera to see what animals could wander across. There really were local birds, local wildlife, and some stray cats and dogs that happened to wander past the camera. So that did have the advantage of having some a large collection of wildlife in our back garden to play with.
Diverse flora and fauna.
Absolutely.
Of APAC, yes, absolutely. So you've got a Raspberry Pi with a camera in the garden, and you're automatically tracking for wildlife and population statistics.
Yes. So if I was to maybe sort of paint a bit of a broader picture here, so Raspberry Pi is sort of a low cost computing device. You probably don't want to put your expensive laptop in your garden, but maybe you're happy to put a $20, $50 low cost microcomputer in your garden, and they're quite amazing computing platforms. You can actually deploy essentially a Linux computer to your back garden with a little camera. And it was sort of a nice project to be able to put like a object detection model on a Raspberry Pi and essentially do some edge processing and actually demonstrate what it looks like when you've got an edge device and you actually want to connect it up to Kafka in the cloud.
It's the thing I like about the Pi is like while we weren't looking, it snuck up and became a serious like high power computing thing that you can just hide under a rock.
Oh, absolutely. And I think the genesis of this project was actually from my day job, where essentially we were using a number of sort of edge devices to do image recognition in the field, and some of this technology is quite proprietary, but you can sort of simulate a lot of that sort of proprietary technology with essentially quite accessible systems such as Raspberry Pi. So it's great to be able to have that capability as a hobbyist and demonstrate some of these same capabilities.
Yeah. So the kind of computer-aided vision stuff, I am completely out of date on. So where do you start with that?
Oh, like many a good project, I think Google is your friend. Other search providers are available, but I should probably stress I would not consider myself a data scientist or a research engineer, but I can essentially find some established Python packages which do the heavy lifting when it comes to things like object detection. And for this project, I ended up using a framework called TensorFlow. TensorFlow is
I know that one.
Yeah. Again, it's a wonderful sort of framework. It's quite open source. It gives you a lot of sort of capabilities. But one of the nice things is it's got a whole community around it, including model detection zoos. So not only do you get the advantage of like a well-opinionated framework for things like object detection, you can actually build on the shoulders of giants to find an object detection library for your own needs, such as identifying animals in your back garden.
Oh, so do you sort of download a specific package for detecting wildlife as opposed to Lego bricks?
Exactly.
Oh, cool.
Yeah, and quite nicely, the TensorFlow area where you go and start looking for these things is called a model zoo. So you go and find an appropriate zoo for identifying, in my case, backyard animals. But you can also find zoos for solving all sorts of things. And again, one of the advantages of something well-opinionated framework is even if the object library isn't completely tailored for your use case, you can actually do what's known as transfer learning to take a model that might be optimized for one use case and tweak it and train it and get it to start identifying Lego bricks or native fauna and fauna.
Okay, so just so I'm understanding this essentially they've pre-trained the neural net on a data set that's relevant to you, and then you just download the pre-trained net.
Correct. Yeah.
That's what we're talking about. Okay.
Exactly. Yeah. And so this is quite accessible, and for a deployment such as to a Raspberry Pi, having sort of wrapper libraries in Python makes it quite accessible. Actually, for this project, I think to be completely accurate, I used a cut down version of TensorFlow called TensorFlow Lite, which is essentially a slimmed down model evaluation library, which is essentially optimized for battery powered devices that you actually want to deploy into a back garden or a field somewhere.
Right, so it's a power thing rather than you're just trying to save money.
Exactly.
Okay.
Yes. But when I want to multiply my real estate, I've now got the capability of deploying hundreds of these to hundreds of back gardens.
All you need is to become a property tycoon and you're away.
I know, but I've got the dream and the vision. It's just execution between here and there.
If anyone would like to fund Simon, please contact us directly at the podcast.
Yes.
Okay, so there's a lot to break down here, but what does it actually look like to program? Because this is something I would like to do at some point. What's the actual Python? I know it's hard on a podcast, but give us an idea of what the coding actually looks like for that.
Yeah, and in short, I'd encourage anyone who's even mildly interested to either look at the project library for the hackathon for my code base, or just look for some of the TensorFlow libraries. They're quite easy to read. But essentially, you've just got for an object detection routine, you've just got essentially a big while loop. You open up essentially a feed to a camera using sort of a Python library. Typically, OpenCV gives you a nice connection to an onboard camera. And for each frame that you bring down, you just do a bit of object masking, essentially like to crop it and to reduce the pixel density. And then for each frame, you apply an inference function, which is essentially an evaluation of the frame that you've got against the model. And then you'll get essentially a Python dictionary back describing objects that it's found in each frame. And then you can keep going through that loop again and again and again.
And is this like probabilistic result? So like there is a 50% chance there's a cat in this frame?
That's correct. Yeah. So you can essentially ask the inference library to look out for maybe cats and dogs and teddy bears, and then it will give you essentially a dictionary back saying, there was two cats and the probability was 50% or 80%. With inference functions, you never get a 100% or a 0%. To your point earlier, everything is a probability, and you apply a threshold against it.
You sort of, I'm sure Schrodinger wishes he had access to this.
Yes. I'm sure there's a pun there, something about probability and cats.
Yeah, gotta be. We'll keep researching on that.
Yes.
So it is actually, it's per frame then. It's not tracking changes in the frame over time.
That's correct. Again, I'm emphasizing here that I'm very much a beginner here, so this is very much the naive implementation of treating each frame independently from one another. So every frame is identified with no relation to frames either before or after it, which did lead on to some almost secondary problems, because it was such a naive implementation that I ended up with a sort of a stream of events that required a level of massaging to actually identify essentially what it meant when you're just interpolating every image frame by frame.
Right. Okay, so let's get into that then. How did you choose which parts to put on the pie, and then when it was time to split everything out, what's your larger architecture?
Yes, yeah. So I think my mental process here was to do essentially just the simplest path, and my ultimate goal here was to count animals and do trend analysis. So essentially the job of the edge device, the Raspberry Pi in this case, was really, really simple. It had to identify things in each frame, essentially come up with a payload and send the payload onwards. And essentially, I guess my mental process here is to make sure that I'm playing to the strengths of the Raspberry Pi, which is it's in the field, it can look at the images one by one. But apart from that, it need do nothing more than just essentially send out a payload of what it's seen in each frame. And all of the sort of processing is best done by, I don't know, I'm going to just say a stream processing framework would be a good place to do that kind of transformation. So I guess the separation of architecture here is image processing at the edge, essentially just get a payload and send the payload, which is essentially objects identified in each frame, and send that off to a Kafka broker for some subsequent processing.
Right, okay. Fair enough. Okay, so take us through the subsequent processing. You've got this fairly frequent stream of that dictionary saying what animal's there and the probability. Do you also include the image itself that it was detected in?
No, I'm not actually sending the image. I'm just actually sending essentially an identifier describing where the image came from, because essentially I did actually want to start building for my eventual goal of having hundreds of back gardens. So every camera essentially has a header payload describing where the image came from. But you're perfectly correct. The payload itself is just essentially just call it a nested bit of JSON, which describes the object seen and the count of each object. So if there were 3 zebras and 2 cats, that's what's sent in that record payload.
And for those zebras that wander through the Australian outback.
well, it's funny that you should say that, because I wasn't joking when I said I actually had multiple endpoints. I did have a Raspberry Pi initially, and then actually souped it up a little bit by having a web feed from a number of local zoos, and it was essentially running the same model. So yeah, it was actually quite important to.
I take back my sarcastic comment. You did have zebras.
Yes, but just to emphasize the point, they weren't my zebras; they were someone else's zebras. So I should just clarify the point around ownership of zebras. So if you're not thoroughly confused by now, just the point here is that there's edge devices, be them Raspberry Pis, sending out payloads. There's another Kafka producer, which is essentially streaming observation events from webcams, and they're all ending up in exactly the same Kafka broker, with essentially just a bit of a payload that describes where the image came from, and just essentially that JSON, which is essentially a dictionary of things identified in each of those image frames.
Right, and is it all just one big topic?
That's correct. Yeah. So everything's landing in just one enormous topic as a sort of a landing area, and then the idea is to essentially do a level of stream processing over and above it, which is both to sort out, which essentially the trends of animal movements. So if you can imagine that across several frames, you might have identified 2 cats in one frame, and then 1 cat, and then in the third frame, 2 cats again. You can kind of infer that you actually had 2 cats, and maybe you just missed counting the second cat in that sort of middle frame. So that's why it sort of made sense for not having that responsibility at the edge device, but maybe moving that processing to a stream processing layer.
So you've got sort of like a smoothing function over it.
Exactly.
How's that actually coded?
So I chose to use ksqlDB and just coded it as essentially a windowing function, which again is in the context of a hackathon is a quick way of achieving an outcome. So
yeah, absolutely.
Yeah, one of the nice things about ksqlDB is you can think through several iterations quite quickly and think, well, actually, what do I want to do? I want to smooth over maybe a trailing 30 seconds and find the highest number of identified animals per class, and that's just a nice construct in ksqlDB to achieve that outcome.
Okay, so you're putting that into a result topic. Is it just raw input topic and smoothed over result topic? Is it just those two?
Correct. Yeah.
Okay.
There was actually sort of to make my life easier, I ended up sort of exploding the JSON payload. So if you can imagine, it's sort of as far as the payload is concerned, it's sort of just a dict structure. So you might have cats, you might have elephants, you might have koalas. And I found it actually easier within the KSQL itself to essentially extract the count of each animal class and essentially pivot it out to be essentially a wide table. And it just made some of the later processing a little bit easier by essentially exploding that JSON into and pivoting it out, so it was just easier to visualize later.
Okay, so do you mean you've got like almost like a separate column for the interesting animals?
That's correct.
Or
yes.
or you've got one row per kind of animal?
No, in my case, there was literally a column called the cat column, the dog column, and the zebra column. And yeah, it was just a quick way to speed the way for some of the visualization and notification systems later. Was just
makes sense.
Those. Yeah,
but you're going to have to extend it to include Tasmanian devils.
That's right. Yeah, one of my short-term design decisions might have a long-term maintenance effort.
It's a hackathon project, right?
Yes.
You're allowed to have future work in the
yes.
notes. So what was your onward processing from there?
Oh, yeah. So although it's sort of interesting to think about this stream processing happening in Kafka, obviously, when you want to demonstrate change of populations or notify on interesting outcomes, you obviously want to send the data somewhere so you can choose to see it and draw some insights from it. So I chose to use essentially a Kibana dashboard, and so using Kafka Connect, it's a sort of a straightforward task to use an Elastic sync connector, send my newly created stream into an Elastic index, and then essentially put a Kibana dashboard on top of it. And that gives me the advantage of being able to build something quite nice, which is like constantly updating graphs and trends, and essentially doing all of that visualization in something like Kibana. And Kibana is quite nice for doing those sort of real time and constantly updating graphs and pie charts and trend analysis. And I guess the path from a Kafka broker into Elastic is just being able to essentially light up some specific Kafka Connect sync plugins. And again, it's nice to just think this as a problem and have the implementation just being essentially some quick bits of configuration. So it's solving some of that integration headache just with some relatively straightforward configuration.
So how much code did you end up with to put this all together?
I think this whole project from beginning to end was probably less than 200 lines of code. So it's probably about 100 lines of Python and just some REST payloads to go and configure essentially the indexes and the configuration for Kafka Connect. And maybe there's, I don't know, I'm going to say 60 to 80 lines of ksql for producing the transformations. So I'm glad I'm not being paid per line of code.
Is there anyone that still does that? I hope that died out in our industry a long time ago.
Yes. But yeah, if you want to think about, how can you build on the shoulders of giants and essentially stitch together some really cool and existing infrastructure and frameworks. I think it's kind of neat to just be able to talk about lighting up these integration patterns and these stream processing patterns with essentially configuration based outcomes. And in lines of code, it's a handful.
Yeah, that seems incredibly low for something that would be that reusable. Like, I was speaking to someone recently who's doing the same area, like tracking for footfall in front of shops and through shopping malls. I can't see any reason why what you've done couldn't be repurposed into that space. Right?
Oh, 100%. I think one of the initial ideas was actually to do a count of the queue length outside my local coffee shop outside my office, and it's exactly the same process. You just want to take a stream, do some object identification, and you actually don't care about the individual pixels. You actually care about the number of people in the queue because you actually care about how quickly you're going to get your coffee on a Monday morning.
Yeah, that would actually be really useful to the business, presumably, as well. Like, when are the peak hours? I mean, to a degree, they'll know. It's one of those things the people in the shop will always know, but the management are probably completely unaware of when those spikes come in.
Yeah, or you could think about it like you know it from the transactions that you get on the register, but you don't know how many people got annoyed because the queue was more than 5 people deep and they wandered off to another coffee shop. So you can actually think about some real world business implications of doing that kind of observational analysis.
Yeah, the kind of drop data stuff that we end up talking about a lot in event streaming. If you capture the raw data, keep it permanently, you get to see not just the successes, but also the failures.
Oh, absolutely. Yeah. And sometimes, if you're thinking about just one problem, you can just count the things that are in front of you. But sometimes the real opportunities are the things that are sort of ancillary or the things that you didn't count.
Yeah. Especially if your competitors aren't doing it, right?
Absolutely. Yeah. You just want to be a little bit better, or if you're solving for the important task of serving coffee on a Monday morning, that could be the thing that you want to measure for and
Monday
optimize
morning,
for.
that's especially worth optimizing. So, how long did you leave this running for, and did you learn anything about the Australian wildlife in your area?
I think I left the initial Raspberry Pi running in my back garden for. It was over a week, so I did actually get a number of interesting encounters in the back garden. And then when I was sort of running some of the zoo observation ones again, that was running for over a week or so, just to prove the viability. It was quite interesting. I was kind of expecting this stuff to work for a few minutes and then fall over, but a lot of these frameworks are extremely robust, and they just keep going.
That's impressive.
Yeah.
And are they reliable? I mean, did you ever get, I've detected a zebra in my back garden, which seems unlikely?
It was actually quite the disappointment to realize there were no zebras in my back garden. But I did get what I thought was a very exciting event. I got a rabbit event, but it was just a misclassified cat, which was highly disappointing.
Perhaps a long-eared cat.
Oh, absolutely. So we live in hope that one day we will find an exotic animal in the back garden.
If you can't find one in Australia, you're not trying. Maybe the camera resolution can't detect all those interesting spiders you have.
Yes. But that does remind me. I think one more things that I wanted to demonstrate in this project was essentially notification of unexpected events. Just to demonstrate, you've kind of got the happy path of being able to build pretty population graphs on things that you were expecting. I put in sort of a second sort of alerting condition for the arrival of, and I chose to do it for the arrival of a teddy bear. So if a teddy bear walked in front of the camera, it actually sent a special alert to my phone. So I'd got instantaneous push notifications if a teddy bear appeared in the back garden.
Do you have kids walking them around?
I do. It was actually a neighbor who walked across with her teddy bear that actually triggered this. So it's very exciting to have the real world appearance of a teddy bear in the back garden. So yes,
a surprise teddy bear. Yeah.
Yes.
I suppose you could use this stuff for home security, but I think right now I prefer your use case.
Yes. But I'm hoping that these ideas sort of can go in all sorts of directions, feed people's imagination. So it was definitely good fun for a hackathon. But I think the real takeaway is that it's really kind of interesting what you can do with a combination of sort of low cost devices, edge processing, existing frameworks, and then being able to sort of integrate it all and stitch it all together.
Yeah. And this is like one reason why hackathons are great, because you get to play, and then when you step back, you realize exactly the same structure has some real world use.
Oh, 100%. Yeah. And it's just been good to be able to like have a bit of like free form creativity and play with some of these things.
Yeah, absolutely. Well, congratulations on winning the hackathon.
Thank you very much, Chris. It was good fun putting it together, and I definitely got the opportunity to play and learn on the way. And it was really great to have the opportunity to play with some new technology and some familiar technology and put it all together to both have some fun and demonstrate an outcome.
Yeah, and presumably at some point, someone at ThoughtWorks will want one of your clients at ThoughtWorks will want this, and you'll jump up as the expert.
It's always good to have a demonstrator, a bit of a thought starter. So stream processing, you can do it for banks, you can do it for vehicles, and you can also do it for zebra and teddy bear identification.
Motto to live by. Well, cool. Thank you very much for coming to talk to us about it. We'll put a link to the source code in the show notes. It's on GitHub, right?
Absolutely. Chris, it's been so good to have the opportunity to talk to you today.
Simon, really great to talk to you. Cheers.
Thanks very much.
I've just realised I didn't ask Simon if he's detected the Great Australian Bunyip yet. That is an oversight. I'll ask him next time. If you want to see more of Simon's project, check out the show notes. There's a link to the GitHub repo for the source code, and I believe he's writing a blog post, which should be linked to there as well by the time you hear this. The blog post, I think, is going to be on Confluent Developer, so that's a good place to look for that, and for a wealth of other resources for learning about event streaming and Apache Kafka with Python, Go, Java, and loads more. Check it out at developer.confluent.io. And to make the most of all that information, you will need a Kafka cluster, so try spinning one up at confluent.cloud, which is our Kafka cloud service. You can sign up and have Kafka running reliably in minutes. And if you add the code podcast100 to your account, you'll get some extra free credit to run with. Meanwhile, if you've enjoyed this episode, then do click like and subscribe and the rating buttons and all those good things. It helps us to know what you'd like to hear more of, and it also helps like-minded people to find us. So I think it's a good thing. As always, my Twitter handle's in the show notes if you want to get in touch with me directly, or if you have an idea to be a guest on a future podcast. And with that, it remains for me to thank Simon Aubrey for lining up the time zones and joining us, and thank you for listening. I've been your host, Chris Jenkins, and I will catch you next time.